Okay, so again, one more time. If you do have a question about the slope of the y-intercept form, because we're going to begin to talk about something new right after this. Okay, so there's going to be three forms of a line that you're going to be responsible for. We talked about standard form. That's going to come back at us in a little while. Okay, that was something we mentioned in the very first section of chapter 2. We talked about slope and intercept form, which is what we're using now. Okay, both of these. Hopefully we'll get these down pat, and then we're going to have one new thing. It's going to be a tool for us to keep answering this question or to do this thing, write an equation. So here, this one, again, when you're given the slope and the y-intercept, this is the easiest form of this problem that I can possibly give you. I am going to put one of these on the test. 3 points. Okay, I want you to get this. All you got to do is plug and chug on this problem. So it's y equal to, what comes in front of the x? Okay, -1/2. Thank you for the more voices. And then what am I going to add on to the end of that? A -6. Perfect. Okay, the slope goes in front of the x, the y-intercept goes on the end. Any questions about that? No. Yes, I love it. Assertively saying no. Okay, so then the other form of the equation of the line, we don't generally keep equations of lines in this format, but this is a tool for us when we're given other information aside from the slope and the y-intercept to be able to form the equation of line. The usefulness of this, okay, many of you are probably going to take statistics at some point. You'll be in a major that you're going to need statistics. One of the things you do is you form correlations, and you have to create lines that match up. So being able to write the equation of a line from some given information is a very useful, practical, real-world tool when you're doing things. Okay, so we're just going to do the math behind this, and then in a future class, you will then use that math for other things. So example 2, this one's my example. Okay, so let me read this. The point slope form. Okay, remember, math people are not super creative. The slope-intercept form told us the slope and the intercept, and we just used that. The point slope form says, okay, now if I have a slope m that I know, and I know I know the line goes through another point that's not the y-intercept, okay, then I would use this format right here. And what I would do is I would take the y value, the y variable minus the y value, whatever it is. Okay, so this right here and this right here, these are from the point that I've been given. And then the m, I'm pretty sure this is probably obvious to you, but I'm going to make sure it is. And the m, just like before, is the slope. Then there's 2 formats to the line, and some of our problems are going to include each. Sometimes you're going to be asked to put the equation of the line in standard form. And remember, standard form has the x and the y on the same side of the equation. And sometimes you're going to be asked to put the equation of the line in slope-intercept form, which means solve for y. Okay, so you're going to start here, and then you're going to end in one of the 2 places. So my problem here in example 2 says write the equation of the line in standard form. We'll worry about that at the end. That's not something to worry about right up front. The slope is 1/2, and it's going to go through the point 5,7. So again, I got a point, I got a slope. It's a straight plug and chug problem to help us remember. So after this, I've got 2 problems just like this to help you internalize this equation that we're using. So here goes. I've got y. What's the y value of the point that I've been given? Okay, so y minus 7 is equal to my slope, 1/2, and then a parenthesis, and then x minus, and I think everybody would notice that the x coordinate of the point we've been given is 5. So I've just put the appropriate bit of information in the appropriate place in this point slope form that I've been given. Again, this helps me remember it because I've had to use it. Any questions up to now in this problem? Okay, when you are asked to do standard form, here is the absolute best thing to do. Okay, I'm just want to make sure this is slightly different. If the problem says slope-intercept form, what I would do is I'd distribute the 1/2, and then I'd add the 7. I'd be done because I'd solve for that y. But to get it in standard form, I want the x and the y on the same side. I don't want to have any fractions. So what I'm going to do first is I'm going to clear that fraction. I'm just going to get that step out of the way. So the only fraction I have is 1/2. So I'm going to multiply every term I have here, and I've got 3 terms. I'm going to multiply every term by what? 2, yes. So I'm going to multiply by 2 right here. I'm going to multiply by 2 right here. There's my second term. And then remember, this is all together. It's being multiplied together. So it's just one term, even though it looks like more. So I'm going to just multiply by 2. I'm going to write it 2 over 1 right there. That's that process of clearing the fractions that we had long, long ago coming back to haunt us yet again. If I lose you, let me know. You're going to do the exact same thing in the next problem. Okay, so you're going to follow these same steps to hopefully help you remember what you're doing. So on the left side, 2 times y is 2y. -7 times 2 is -14. I have 2 times a half. The 2's cancel and leave me a 1. So I just have 1 times x minus 5, which is x minus 5. Standard form. Again, reminding you for the 3rd time, because I know I just mentioned it in passing on the first day of this chapter. In standard form, you put the x and the y on the same side. You have put the number on the other side. So I'm going to bring this x over by subtracting it. And I'm going to bring the 14 to the other side by adding it. So on the left side, here's what I've got. I've got -x. I've got plus 2y. This 14's gone. This x is gone. And then -5 plus 14 is 9. And there you go. There's your answer to the problem. I'm going to give you one addendum, and this is for my math lab only. Okay, so I'm just going to write that. When you take my test, if I give a problem and this is the answer, you're done. There's nothing else you have to do. That's standard form. But some students last semester told me that my math lab gets fussy about standard form. I don't know why, because it's not technically standard form. My math lab likes the x to be positive, not negative. So if this happens on a my math lab problem, when you're doing your homework or taking your quiz, all you have to do here is just change all the signs. Maybe they're trying to save data space by not having all the different options. I don't know why, but since the x is negative here, what I'm going to do, this is my math lab only. I'm going to go x minus 2y is equal to -9. I just changed all the signs of each term. That's the way my math lab is going to want it. Again, either way is fine for me because both of them are standard form. Okay, they're the same equation. All right, exercise 3. I'm going to leave that problem right there so that you can see it at the top. Exercise 3 is the same thing. I've just changed the numbers so that you can give it a try. All right, so the first part to this problem and the new part to the experience here is using this point slope form as my first step. So in this particular problem, my point is -1, 3. My slope is 3/4. So here we go. I've got y minus what value? It's -3, but yeah, I think that's what you meant. And then on the other side, I have 3/4. And when I do x minus -1, what does x minus a -1 become? X plus 1, yes. Okay, so that's the new bit. If you were able to put the numbers in the right place, that's good. The rest is busy work. And that's the reason I've given a second example for you to do in just a moment, is to correct any errors in the busy work, because I know we don't necessarily love that. So since I want to put this in standard form, that's what I've been asked to do. We're practicing that. I'm going to get rid of that fraction. What am I going to multiply every one of my terms by? 4. Again, this is another situation where once you've done 1 or 2, you've seen all the steps. It's just a matter of remembering those steps. So I'm going to multiply everything by that denominator of 4. So multiply by 4 there, multiply by 4. I should have thought ahead and left myself a little more room, but we're just lucky that I showed up. All right, so here we go. So on the left side, I've got 4y. 4 times that -3 is -12. On the other side, the 4's cancel. That leaves me a 3 outside the parentheses. And don't forget to distribute that 3, okay, because I've got parentheses. So it's 3 times x is 3x. And then sometimes students forget, and that's why I'm mentioning it again. 3 times 1, I've got to distribute, and I've got +3. Everyone see where I got everything from there? We okay? I'm going to put a problem just like this on your test that you're going to take a week from today. There should be no mysteries. If you've attended class every day, if you've gone through the worksheets, there will be absolutely no mysteries on the test. If you've done the homework, you've taken the quiz, you're going to be prepared for the test. No, it's Monday. Or no, what's today? It's Tuesday. Next Tuesday. We have one more section in this unit to do, and we'll do that on Thursday. Okay. All right, so continuing. Now the rest of this. X is on the same side, and y is on the same side, numbers on the other. So I'm going to subtract the 3x to get it over here. I'm going to add that 12 to get it over on the other side. And so here's my standard form. I will be done with the problem in just a minute. So I have -3x. I have +4y is equal to 3 and 12 is 15. If you change the signs on each of the terms, thinking ahead to when you have to do this on your homework, and have +3x minus 4y equals -15, that's equivalent and fine. I accept either answer on the test, but I'm lazy. I'm not going to do any more. All right, one more, just like this. Same problem so that you can work through any issues and make sure to ask any questions. Do exercise 4, please. All right, so I'm just going to get started here. If you're still working, keep working. We'll meet up. I've got a point. I've got a slope. I've been asked to put this in standard form one more time because we're practicing that. So I have y minus and then -6. So y minus a -6 will be y plus 6. And then my slope is -2/5. And then I have x minus 3. So I've put the appropriate information in the appropriate place. If there's a question about that, raise your hand, shout it out, be bold, okay? Make sure that you leave here feeling pretty confident about this. Once again, since we were asked for standard form, I'm going to get rid of that fraction by multiplying everything by 5. Okay, that's the only denominator I have, so it's what I'm going to multiply everything by. So everything gets multiplied by 5 there. So 5 times y is 5y. 5 times 6 is plus 30. On the other side, the 5's cancel, leaves me with a -2 outside the parentheses. So -2 times x is -2x. -2 times -3 is plus 6. Again, the first step, that's what you have to remember, putting the appropriate values in the appropriate place. The second step becomes the busy work. Yeah. Why is it plus 6? Well, when I plugged into the equation, this is x minus 3, right? It's x minus the x value. So my x value was 3. So it's x minus that 3 right there. And so then I have this -2 outside the parentheses. So -2 times the positive x gives me -2x. -2 times the -3, and negative times a negative is positive 6. Okay. That's okay. That's why I'm here. All right, continuing, I'm going to now get all the x's on the same side, plus 2x to both sides. I'm going to bring that 30 over to the other side, like so. And so here's what we've got. We've got 2x plus 5y on the left. And then on the right, 6 minus 30 is -24. There we go. All right, to sum up, if I'm using the point slope form of the equation, which we're going to continue to use, what 2 bits of information do I have to have? I need a what? I need a slope and I need a point. Okay, I need those 2 things. That's why it's called the point slope form of the equation. I need a point and a slope. For the first 3 problems, we were given exactly that, a point and a slope. And now for the other, there's 2 more types of problems, just variations. You're just going to be given slightly different information, but you need to end up with a point and a slope in order to be able to do this. So next problem, this is my example down at the bottom of the page. It says, write the equation in standard form. Okay, that goes through these 2 points, -4, 3, and then 5, -7. Okay, well, let's take an inventory here. Am I given a point? Yes, in fact, I'm given 2. We'll deal with that when in a little while. Am I given the slope? No, but do I have enough information to find the slope? Yes, this is where we get to review what we did last class, finding the slope. Okay, so we're going to incorporate some of that knowledge. So if you haven't quite caught up, that's okay. When I find my slope, what's my process? I do what in the numerator? Fantastic. I love that boldness. Thank you. y2 minus y1. So I'm going to say -7. I'm just going to call that y2 because I have the pen, so I'm allowed to. So -7 minus 3. But remember, I told you it does not matter what order you do that. You could do 3 minus -7 in the top. You just have to be consistent. But since I said -7 was my y2, what's going to be my x2 in the denominator? Okay, 5 minus -4, so 5 minus a -4 becomes 5 plus 4. And so my slope, the numerator is -7 minus 3, that is -10. 5 plus 4 is 9, that doesn't reduce at all, there's my slope. Okay, so I just had 1 extra step on this problem. Okay, it's just something that allows me to bring in some previous knowledge. So now I have a point, in fact I have 2. We'll talk about that in just a minute. And I have a slope. Now I'm ready to use the point slope form. Here goes. The point slope form says take the y variable minus your y value. So here's where you have a choice. Both of these points are on the line. It doesn't matter which one you pick. Just again, be consistent. If you pick one, use it. Which one do you want to use? 0.1 or 0.2? Okay, that's what I heard first. So I'm just gonna circle it so I don't make any mistake. 0.1. By the way, if you used 0.2, you will end up with the exact same equation. Okay, it will be no different. Okay, so don't think that you're choosing, if you choose the wrong point here, you're going to get the problem wrong. You can't get the problem wrong unless you mess up the arithmetic. Okay, but it won't be because you picked a different point. So I've got y minus 3 is equal to, that's a terrible equal sign, negative 10 ninths x minus negative 4. So that's x plus 4. And at this point, it's the exact same problem we were doing before. Standard form, get rid of the fraction and then put the x and y on the same side every time. It's the same thing. Okay, so what I'm going to do now is multiply every one of the terms by what? 9. Great. I appreciate all the voices. Thank you for still being awake. So that leaves me on the left 9y minus 27. On the right, the 9's cancel. I have a negative 10. Negative 10 times x is negative 10x. Negative 10 times 4 is negative 40. Standard form just means get the x and the y on the same side. So we're just about done with the problem. There's I added the 10x. I'll add the 27 to get the numbers on the other side. And here's my final answer. On the left, I've got 10x plus 9y. On the right, negative 40 plus 27 is negative 13. Does that seem okay? You need a point and a slope. The challenge to this problem was you had to find the slope. I'm going to flip the page. I'm going to give you a minute or two to at least get a healthy start on exercise 5. I think we got 2 more problems, and we're going to do standard form so that you don't forget it. And this is the first of those 2. I'm going to get started because we got a couple steps here. Again, we're asked to write the equation of the line in standard form through these 2 points. To use the point slope form, I need a point, which I have, and I need a slope, which I don't have, but I can find. So step 1 is I have to find that slope. Okay, so maybe you've done this, or maybe you're still working on it. The slope is the difference between the y's and the top divided by the difference between the x's and the bottom. Slope is always the ratio of rise over run. Again, it does not matter which one's your y1, which one's your y2. You can do that in any order. I'm just going to make the -4 my y2 minus 5 my y1. If you did this the other way, okay, I made a big point of this last time. We should have the exact same value for slope, no matter what. And then my difference between my x's is going to be 1 minus -2, so 1 plus 2. So in this one, -4 minus 5, that's -9. 1 plus 2 is 3. And so this one, finally, we have one without a fraction. Okay, it's just -3. Anybody get something different for the slope that we have to investigate why before we move on? If you got a +3, then you made the mistake of changing the order of your, which one was the second point, which one was the first point. Okay, a minor thing, but go ahead and make sure you note that. If you got 1 over -3, then you did run over rise, and that's not slope. Okay, those are the common mistakes. That's why I do so many of these problems, is I just want to make sure that you avoid those things. Now I'm going to use the point slope form. I don't care which point do you want to use? Somebody tell me. First one? Sure. So here we go. I've got y minus 5 is equal to -3, x minus -2, or x plus 2. By the way, I'm sure probably at least half of you used the other one. So your equation here is y plus 4 is equal to -3, x minus 1. We'll all end up in the same place. Okay, so don't worry. At this point, I don't have a fraction to clear, so I saved myself just a little bit of work. So I have y minus 5 is equal to -3x minus 6. I'm going to get that x on the same side. I'm going to add the 5 to get all my numbers on the other side. And here is my equation of the line. It is 3x plus y is equal to -6 plus 5, or -1. Feel okay? I'm hoping you'd ask a question if you don't. Get started with exercise 6. If you need me for anything, raise your hand. I'll come to you. I'll help you. I'll help you in case you're just that shy that you don't want to ask a question in front of everybody. Okay, once again, I'm going to get started. I'm not trying to rush you, just trying to cut it down the middle. Some people are done, some people still working. So if I goof you up, you have any questions, be sure to ask them. Okay, so once again, this is the same style problem we just did. Point slope form means I need a point and I need a slope. I've got points, I need the slope. So I'm going to start there. So the slope is equal to the difference between the y's in the numerator, difference between the x's in the denominator. Previous two problems, I've used the second point as y2. I'm just going to reverse that because I don't want anybody to think that I've got any sort of hidden mysteries that I'm not telling you. So I'm going to do my change in my y's. I'm going to make -4 minus -1, or in other words, -4 plus 1. That's my difference between my y's. And then my accompanying difference between my x's is if I've made the -4 my y2 minus my y1, that means my 3 is my x2 minus -2, so 3 plus 2 in the denominator. However you did it, we all should be staring at a slope of -3/5. You either got -3 over 5 like I did, or you got 3 over -5. One of those two, but either way, it's the same thing, -3/5. Now I'll use that. I'm going to pick a point. I don't care which one. You don't care which one. It doesn't really matter. I'm just going to pick this one because the numbers are a little bit smaller. That's the only thing I'm thinking. I'm lazy. Okay, so now I'm going to plug that in. So I've got y minus my y value, which is -1. So that's y plus 1 on the left. Then I have -3/5, x minus my x value, which is -2. So that becomes x plus 2. If you used a different point, again, I've said this before, I just want to make sure that you're hearing it, you'll get the same thing. Okay, there's no other answer to this problem. I need to get rid of that fraction for my standard form. This is my last standard form problem on the sheet. So I'm going to multiply everything by 5. So on the left, I have 5 times y plus 5 is equal to, on the right, the 5's cancel, and I have that -3, so it's -3 times x is -3x, -3 times 2 is -6. And finally, last but not least, I'm going to get the x and the y on the same side. I'm going to put all of my numbers on the other side, and then I'm going to be done with this problem. And I'll be ready for any questions you have before we move on to the last alteration of this problem. So I have 3x plus 5y on the left. On the right, -6 and -5 is -11, and I'm done. So we've spent, and we're going to continue to spend the rest of our time finding the equations of lines. The first type, the very straightforward plug and chug, was if I give you a slope and a y-intercept, you just plug that right away in the slope-intercept form. Unfortunately, that's not always the information we're given. So then we did the point slope form, where I just gave you the point and the slope, plug and chug. The last 3 problems, I've given you points and you had to find the slope, but it's the same thing in essence. And the same thing is going to be true of my last example and the last couple of problems on the sheet. I do have one extra thing to say, so don't pack up when we're done with exercise 8, or you'll miss something, and I don't want you to have any consternation on the homework. And so the last one says this. We're going to write the equation of the line. This time we're going to use slope-intercept form. That's fine, no problem. And it's going to go through the point 6, -3, and parallel to this line right here. So once again, my tool that I have is the point slope form. Do I have a point to plug into that? Yes, it's given to me straight away. It's 6, -3. Am I given a slope? No, but again, am I given the tools to be able to figure out the slope? Yes, remind me, this word parallel, again, more review of what we did last time. The word parallel, what does that mean? Same slope. So what that means is I want my line to have the same slope as this line right here. So that means I have to find the slope of this line right here. How am I going to do that? How did we do that last time we were together? Solve it for y, put it in slope-intercept form. Exactly right. So let's do that. You've done this a couple dozen times now, so I'm not gonna mess around with you. because I know that as a responsible student, you would ask me a question if you had one. So we've got 3y is equal to negative 2x plus 6. Divide by 3. And I end up with y is equal to negative 2 over 3x plus 6 over 3 is 2. I want my line to be parallel to this line, meaning I want my line to have the same slope as this line. So what is the slope that I'm going to use? All right, I'm just going to write that right here, negative 2/3. I don't care about the y-intercept of that line. It's immaterial to me. All right, now I will continue and finish this problem. I've got the information I need. I've got a point. I've got a slope. I'm ready to rumble. So let's do this. Now this problem is exactly like every other problem that we've done in the last 6. There's absolutely no difference from here on to the end. So it's just the busy work. So I've got y minus my y value, which is negative 3. So that's y plus 3 is equal to negative 2/3 x minus the x value, which is 6. I'm going to get rid of that fraction. You would tell me, I know you would, multiplying everything by a 3. So what that gives me on the left of that is 3 times y is 3y. 3 times 3 is 9. On the right, the 3's cancel, and I'm left with a negative 2 outside of the parentheses. So negative 2 times x is negative 2x. And negative 2 times negative 6 is plus 12. Last step. Oh, no, not the last step. Sorry, I probably should have done this differently, but we can salvage this. I'm sorry. I was in cruise control, wasn't I? Because yes, Mr. Perkins, you were. I'm noting this on your evaluation. Bad, professor. Okay, so what's different about this problem than the previous one that I didn't need to do what I just did? I said slope-intercept form on this one. So I could continue on and get the slope-intercept from that, solving for y. Maybe that's the best thing to do, but let me just show you what I probably should have done straight away. So either way you want to do it, if you just want to finish solving this for y, since I was in cruise control, you totally can. But what I'm going to do is I'm going to rewrite what I have here and show you what I should have done. It's a little bit more direct way to do it. So it doesn't really matter. Since it's slope-intercept form, I just want to solve this for y. So it's just 2 steps, but it's a different 2 steps. This time what I'm going to do, because I want to solve this for y, I want to be able to subtract this 3 from both sides and be done. So what I'm going to do first is I'm going to distribute. Okay, the fraction's fine in slope-intercept form. So I'm going to first distribute. So I've got the y plus 3 is equal to negative 2/3 times x. So that's negative 2/3 x. And I know we don't necessarily love fractions, but in fractions, you multiply your numerators, you multiply your denominators. So I've got negative 2 times negative 6, that's plus 12. And then 3 times the 1 that's below that 6, even though it's not written there, 3 times 1 is 3. Now you can probably do that in your head, but I just want to make sure that it's there for your notes. So I've got an extra step. I apologize for the ink that I'm wasting on you and me. And so just one more time, I'm going to just reduce that fraction. So I've got negative 2/3 x plus 4. And now I'm ready to subtract that 3. So I've written down more stuff than you need to, but I just wanted to be clear. I didn't want to lose anybody on this fraction step right here. And so I have y is equal to negative 2/3 x, and then 4 minus 3 is plus 1. So notice, my final equation of the line has a slope of negative 2/3. The line that I was given has a slope of negative 2/3. They're parallel. And that's exactly what I wanted. So I'm going to leave that right there. You've got the same thing to do with one minor difference. Your problem says perpendicular. In fact, I've given you the same equation to minimize your work right here. So again, review. What's true about the slopes of lines that are perpendicular? Okay, there you go. Both those words. negative reciprocal or opposite reciprocal, either word that you want to use there. So you got to flip the sign, and then you've got to flip the fraction. All right, so give that a try. This is the same equation as the previous one, so you already know what the slope of the previous line is. That save you a little bit of busy work on this problem. All right, so just to get this started, I used the same equation here from the previous problem. We've already solved this one for y. So the slope of this line we said in the previous problem was negative 2/3. So if my line is perpendicular, what's going to be the slope of my line in this problem? Positive 3/2. Negative reciprocal means flip the fraction. So instead of 2/3, it becomes 3/2. And then the negative of that, or the opposite of that, is instead of a negative, it is going to be a positive. So there's my slope. That's the slope we should all be using on this problem. These are the two types of problems you're going to see in the homework. You're either going to do a parallel problem like I did, or a perpendicular problem like this one. It's just another way to help you review some material from last section. Okay, parallel or perpendicular. So now I'm going to do the same thing we did, that's in green ink right above. So I've got y minus the y value, which is -3. So that's y plus 3 is equal to my slope, which is 3/2, x minus the x value, which is 6. I'm going to be a much better professor on this problem. This asks for slope-intercept form. So since it's slope-intercept form, I just want to be able to get rid of this +3 to solve for y. So before I do that, I'm going to distribute right here. So I have something that I can subtract that 3 from. So let's do that. So when I do that, 3/2 times x is 3/2 x. That's always going to be the easier part. You just write the fraction in front of the x, and then minus. Now this time I have my fraction times 6. So 3 times 6 is 18. 2 times the 1 that's not written there is 2. And we know that is 9. So I'll rewrite that. Again, if you can do that in your head, that's great. I just don't want to make any assumptions and trip somebody up on something that's not that big of a deal once you get used to it. So -18/2 is -9. Everybody see where I'm getting my numbers from? All right, last thing to do now, and this is the whole point, is slope-intercept form. So I want to subtract that 3, and I get y is equal to 3/2 x minus 12. So if we graphed both of these lines on the same Cartesian plane, they would be perpendicular, meaning they meet at right angles. I've got one more problem written on the page and one more thing to address to prepare you for your homework. So just go ahead and do exercise 8. Same sort of thing. Okay, so one more time, we're going to write the equation of the line, again in slope-intercept form, so I'll keep that in mind. It's through the point 9, -1, great. And parallel, okay, parallel means equal slopes, parallel to this line right here. So I'm going to find the slope of this line by solving it for y, which I tried to be reasonable on this one because I know you've done a lot of problems. All this is subtract the 3x, and I get y is -3x plus 5. Since my line is parallel to this line, what's the slope of my line going to be? -3. I just want to call a timeout on this problem. Okay, again, I just want to make sure I'm being thorough and helping everybody. What if the problem said perpendicular? The slope would be +1/3. Flip the fraction, change the sign. Okay, so that potentially could be a problem when you're doing your homework. So I just want to make sure that we're all up to speed on how to find the perpendicular slope if that's what you're asked for. But that wasn't what we were asked for. That was just me trying to be a good professor and make up for my shortcomings. And so now we're going to finish up this problem using the point slope form. So I have y minus my y value, which is -1. So that becomes y plus 1. And then my slope is -3 because that's the parallel slope, x minus 9. All right, so we're almost done. Y plus 1 is equal to -3x plus 27. And when I subtract the 1 from both sides, I get y is equal to -3x plus 26. We feel sort of comfortable with that? Yeah. Anybody not? Any questions? Anything that I am not clear on? Okay, so one more thing, just because when you're doing your homework, I don't want you to curse me any more than you already do. So you might be asked this question, and this goes back to section 2.1. I just recommended you remember something. What is the format for any horizontal line? Uh-oh, my pen is running out of ink. Let's try again. Lovely purple. What is the format of any horizontal line? A horizontal line is always what? Y equals your number. Okay, and so then any vertical line is x equal to. Since we've got a minute, I'll ask you another question. What's the slope of a horizontal line? Anybody remember that? 0. So horizontal line has no rise, so it's 0. What's the slope of a vertical line? It's undefined or no slope is usually what I think the choice is. In my math lab, I could be wrong on that, but those things mean the same. Undefined or no slope, it doesn't have one. So you might be asked this question. Okay. So write the equation of the line. And I'm just going to pick one, doesn't matter. Write the equation of the line that is horizontal, or you might be asked slope 0. Okay, same thing, that is horizontal and through, let's go 7, 4. So there's some variations of this that you'll see in the homework, but I just asked you questions to review all those variations. A horizontal line has a slope 0. A vertical line has undefined slope or no slope. So the way I wrote the problem was write the equation of the line that is horizontal and through 7, 4. I could have said write the equation of the line that has a slope of 0 and is through 7, 4. Same question. So here's how you address it then. Horizontal. You've already answered this. We already wrote it down. Horizontal means it's y equal to a number, so it's y equal to something. And according to the point that I gave you, it's going to be y equal to what? The y value, 4. Great. I'm not going to write it down because I'm out of room, but we still have a couple minutes, so I want to make sure you get your money's worth today. What if I said, write the equation of the line that is vertical, or that has no slope and is through 7, 4? That would be what? X equal to, because a vertical line has an equation x equal to, the slope is undefined, but it does have an equation, okay? So it would be x equal to what number? The 7. Excellent.